Okay, so we're looking at question 29 on the review exercise. Please take a look at the question if you haven't already done so and have a go. Okay, so it says find the values of A and B given those conditions. So the key thing here is if we look at the I component, and let me just highlight that, 6i plus lambda I has to equal to 0. Okay, so from the I component, we know that lambda has to equal to -6. And therefore, we can substitute lambda is equal to -6 into the equation of the line to find the values of A and B. So I'm just going to do that. So I'll write this as a column vector. So R is equal to 6, 19 minus 1 minus 6, 1, 4 minus 2. And that gives me 0 minus 5, 11. Okay, so the value of A is -5 and the value of B is 11. So the second part, part B. So part B says the point P lies on L1 and is such that OP is perpendicular to L1, where O is the origin. Okay, so if I have a line here, and let's say this is the point P, which lies on the line L1, and let's say the origin was here. Now we know that OP is perpendicular to L1. Does that make sense? Now, for any point P that lies on the line, it must satisfy that equation. Okay, so we know that OP dot the direction vector 1, 4 minus 2 has to equal to 0. We know that because P lies on L1 and we know that OP is perpendicular to L1. So OP dot the direction vector. Let me highlight this. When they say perpendicular to the line, they mean perpendicular to the direction vector of the line. So OP must be of the form 6 plus lambda as a column vector, 19 plus 4 lambda minus 1 minus 2 lambda dot 1, 4 minus 2 is equal to 0. Very important. Any general point on the line L1 must be of this form, depending on the value of lambda. Okay, so we write that point OP in this form. That's the position vector of P. So if I just do the vector dot product, multiplying the corresponding components and adding, I should get 0, and I have here a very simple linear equation to solve. Okay, so now if we do a simple multiplication and remove the bracket, collect like terms, we have this. And we can say that therefore lambda is equal to -4. Once I have that, it's very straightforward because I can substitute lambda back into my equation of the line. Okay, and so I have the coordinates, because remember, I have to find the coordinate or the position vector of P. So if I substitute that into the equation Let me just do that now. Okay, so we substitute lambda is equal to -4 into the equation of our line. Let's do that now. R is equal to, I can put it into here, can't I, really? So it's going to be 2, 3, 7.